Alrighty, here we go. This is section 2.1, actually the first section in your second chapter of your book. If you haven't looked at the introduction to trigonometry, I'd suggest you have a quick glance at that, because I'm going to assume that you understand what it is that I'm talking about right now. Okay, so in that video we talked about how we name sides here. If this is the angle we're looking at, right, this is the opposite side. You shoot out of the angle, that's the opposite side. This is the adjacent side, it's beside, and the hypotenuse is always the long side. It is opposite that right angle. Now, I guess it depends what angle we're looking at, because sometimes we might be looking at this angle up here. And if we look at that angle up there, then the one thing that doesn't change is the hypotenuse. But this now, the bottom becomes my opposite, and this angle is beside, so the O and the H change. And what also might confuse you sometimes is when we have a triangle that is in a different orientation. Okay, this is the right angle. If I'm looking at this angle right here, can you identify what's O, what's A, and what's H? Okay, that is crucial in doing these questions. So hopefully you can see the long side is right here, and it's always opposite the right angle, so that's the H. The other one, the O, is relatively easy to find too, because you just shoot out your angle and you hit the opposite side. And the other one that touches this angle is the A. And that would, again, these two would change again if I was talking about that angle there. So this is one concept that you need to grasp before we can move on, or by the end of this chapter, you're going to have to make sure that you know how to do that. Okay, so what we have here, the first ratio we're going to look at is what we call the tangent ratio. And the tangent ratio compares the opposite to the adjacent. Okay, it's always going to be tangent, and what we do is we take tangent of our angles. Okay, so tangent of the angle will be the opposite side over the adjacent side. Okay, that's the ratio. Remember I talked about three ratios. We can compare these two, we can compare these two, or we can compare these two. And we're looking at this first ratio, the opposite to the adjacent side. And the ratio of these two sides, the ratio of the opposite side to the adjacent side, depends on what this angle is, right? If it's bigger, what happens to your O and your A, right? This side becomes longer, this side becomes shorter. So the larger your angle, the larger the tangent ratio. Let's look at our table. Look at the tan, right? Small angle 0. As your angle increases, your tangent ratio increases as well. Okay, all the way up till we get to 1. All right. Actually, no, it goes even higher. Sorry, that's for 45 degrees. And then it starts over here, 46 degrees. We keep going up, 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 up. Okay. So as the angle gets bigger, your ratio gets bigger. Okay. Now, let's look at how we're going to do this. So first of all, if I gave you a triangle that looked like this, and I was looking at that angle there. So let's actually not even do that. Let's go D, E, and F. F being my right angle. Now, if I asked you to find, well, let's put some numbers in here, 3, 4, and 5. Let's just use a 3, 4, 5 triangle. Okay, Pythagorean triplet, 3, 4, 5. Now, if I asked you to find tan D, what two sides would you compare? What's your opposite and what's your adjacent? And again, if I asked you for tan E, what would be the two sides that you use? So if this is D, the tan is opposite over adjacent, so it's going to be the 3 over the 4. And if I'm looking for the tangent of angle E, well, now we switch it around. This is the opposite, and this is the adjacent. So it becomes 4 over 3. Okay? That's the very first thing that we need to do. Now, what we want to do is we actually want to find the angle. Find the angles. Okay? So let's look at D. I know that tan D is equal to 3 over 4. Now, if you did the math here, you'd get 0.75. I'm going to show you something here very cool, okay? The ratio of this side to this side is 0.75. Well, that's what these numbers are on here. Can you find a number in here that's 0.75? the closest one you find is right here, right? 0.75 is just a little bit, this is a little bit more, so my guess is going to be around 36 point something, right? Well, how do we do this? We do it on our calculators. We turn our calculators on first of all, and what you do, see the tan button? Hold on, how am I going to do this here? Okay. Well, what I'm looking to do, wait, I can sort this out. There we go. So what I'm looking is to find the angle. So what happens is you go tan minus 1 of 0.75, and that's going to equal D. And tan minus 1 is above your tan button. So you're going to go second 10 of 0.75, and boom, there's your answer. Close to 37 degrees like we just said, right? 0.75 right here, just below 37, 36.9 to be exact. So that's 36.9 degrees. That's the size of that angle. Now, if I asked you to find find angle E, there are a couple different ways you can do it, right? You know that all three add up to 180. These two add up to 90. So if you go 90 minus, let's go 90 minus, what did we have? 36.9. That means that E should be around 53.1. And now we'll be able to make sure and see if this is right. Is that true? Okay, so let's have a look. So tan E is equal to, well, we got it up here, it's equal to 4/3. When you do a decimal, that's going to be 1.333333 repeating. Okay, now let's look on here. Oops, wrong sheet. Let's look on here and see if we can find 1.33333. 1.3, it looks like it's around somewhere between these two numbers. Close to this one, 53, so just above 53. That's pretty much what we have. But what we can also do is use our calculators. We go 10, sorry, capitals, not capitals, doesn't matter. I just keep mixing it up, okay? My apologies. Don't let that screw you up. Tan negative 1 of 1.3333 repeating is equal to E. Well, now let's go second tan, 1.3, put it as often as you want, hit enter, 53.1. Same thing, so we got E. This is absolutely correct. E is equal to 53.1. All right. Now, that's most of what we're looking at. What I'd like to quickly show you is when we're going to have actual problems, like actual questions that deal with real-life type problems. You might be asked for the angle to the top of a tree or to the top of a building. You might be given the angle to the top of a building. We have this thing called a chronometer that measures what we call angle of inclinations or elevations. And what that means is that it's measured from the horizon up. Okay, so this right here is what they call the angle of inclination. Okay, and it could also be called the angle of elevation. There's another way to look at this. I'll show you another one. Say this is your eye right here. Okay, this is the horizon, always shooting straight out, right? Sometimes we look up. We call this the angle of inclination. It can also be called the angle of elevation. And then if we look down, this right here can be called the angle of depression. Okay, because you could be at the top of a building looking down, or you could be at the top of a tree looking down, top of a whatever looking down. Okay, angle of elevation is from the horizon up. Angle of depression is from the horizon down. Okay, so let's just look at another question. Find the angle of inclination. Okay, find angle of inclination. Okay, if you have a triangle that looks like this. Let's call this 15, let's call this 21, and let's find the angle of inclination. So if it's oriented this way, that would be the angle of inclination. Okay, so we're going to go tan theta is what over what, right? over 21. Now, what am I doing here? Yes, so 15 over 21. Let's go 15 divided by 21. I get 0.714. That's good enough, 0.714. So 0.714. You can look at your tables here. Find under the tangent column, you can find 0.714714, boom, right between these two, about halfway. I'd say it's 35.5 degrees, between 35 and 36. So let's say theta, let's go about 35.5 degrees, maybe. Well, let's check it out now. We can do the math, right? Tan -1 of 0.714 equals, and now second tan of 0.714, and we end up with 35.5 degrees, bang on. Okay, so our guess was right on using the tables. This is basically what we're doing in lesson 2.1. How you do this inverse tan depends on what calculator you have, okay? Sometimes you have to hit this button first, like I do, and then do it, or you actually put 0.714 in and then hit second tan. I'll have to show you how to do it on your calculator, but I'm pretty sure that you can get it dialed.